Hey class, welcome to exercise 6A, review of length. We're going to continue our first geometry unit of this year, but this is the beginning of the second block in that unit, which is all about measurement. So in this class, our first example will be example 1, finding the perimeter of polygons. And your pre-learning for this will be questions 1 and 2 in the new book and questions 4 and 5 in the old book. Then we'll move on to example 2, which is using the formula for the circumference of a circle. And your pre-learning for this will be questions 4 in the new book and question 7 in the old book. And then our last example for the class will be example 3, where we'll be finding perimeters of sectors. And your pre-learning for this example will be questions 5 in the new and questions 8 in the old book. Okay, so this lesson obviously is going to be revision for most of you. So we're going to hopefully move through it quickly, but there are a couple of explanations that I'd like to give you that go well beyond what you've learnt before, which might help you understand why some of these formulas have to be true. And in this lesson, I'll be laying the groundwork for some challenges in our next few lessons that I do expect you to do as your extra learning for this block. All right, I'll see you in the introduction. Measurement requires something to compare objects with. So this makes a unit of measurement important. In Australia, we use the metric system. That fits in well with our base 10 number system. Let's quickly revise how to convert between different metric units of measurement. So inside every 1 kilometre, there is 1,000 metres. And inside every metre, there's 100 centimetres. And inside every centimetre, we've got 10 millimetres. So this means that if I, for example, had 3.8 kilometres, then I have 3.8 times 1,000 metres, which is 3,800 metres. And that's just by substituting in the 1,000 metres for each kilometre. And we can continue this down through all of our metric units. So we can substitute in 100 centimetres for each metre, which now gives us 3,800 times 100 centimetres, which is 380,000 centimetres. And finally, we can sub in 10 millimetres for each centimetre. So we now get 380,000 times 10 millimetres, which is equal to 3.8 million millimetres. Of course, we'll need to use division if we move into the other direction, i.e. 385 centimetres is equal to 385 divided by 100 metres, which is 3.85 metres. So we better rewrite this diagram at the top here. So the amount of kilometres we have multiplies by 1,000 when we go to metres, and the same from metres to centimetres and centimetres to millimetres. And moving in the other direction, we need to do the opposite thing of multiplication, so that is division. If I divide the amount of millimetres I have by 10, it tells me how many centimetres I have. And the same with centimetres, I need to divide that by 100 to tell me how many metres I have. And divide metres by 1,000 to tell me how many kilometres I have. Alright, so that's the only thing that's worth mentioning in the introduction here. Everything else that we need to learn in this lesson will be much easier to be covered in the relevant sections for them. So let's leave the introduction now, and I will see you in the next section. The perimeter is just the length of all the edges around a polygon. To find the perimeter, we can measure each one and just add them up. This also means that if we know the total perimeter of a shape, we can find the length of one of the edges if we have the length of all the other edges. In this section, we're only going to look at polygons which have straight edges. However, this is true for all shapes. Alright, so let's move straight into example 1, where we're going to work with this polygon, and the edges are 4.5 metres, 2.1 metres and 3.4 metres. And there's this mystery edge that's length x metres that is, of course. Alright, so question A asks us to find the perimeter when x is equal to 2.6. Alright, so as we've stated already, the perimeter is just the sum of all the edges. So this is nice and easy. P must be equal to 4.5 plus 2.1 plus 3.4 plus that 2.6 for x. Of course, this is metres, but we can add it in later. And adding up 4.5, 2.1, 3.4 and 2.6 is 12.6. So that means that the perimeter equals 12.6. And let's not forget that it's metres. All right, so that's so straightforward. Let's move straight on to part B, where we'll be finding x when we know that the perimeter is equal to 11.9. So because we know the perimeter is equal to the sum of all the sides, let's just write out that sum and leave x as x. So 11.9 must equal 4.5 plus 2.1 plus 3.4 plus x. And because 4.5 plus 2.1 plus 3.4 equals 10, that means that 11.9 equals 10 plus x. And subtracting 10 from both sides, that means x has to equal 1.9. You actually don't need to write in meters at this point because x is just a number, okay? Meters is the unit. All right, let's look at question C, where they ask us to write down x as a relation to p. So if we just leave p and x as they are and write out our formula, we now get p is equal to 4.5 plus 2.1 plus 2.6 plus x. And we've already summed up these numbers before, so we know that p is going to equal 10 plus x. So that's one way of looking at the relation. The other way of looking at it is that if I subtracted 10 from both sides, x is equal to p minus 10. You'll need to read carefully which one that they want. All right, so that's really straightforward. I'm guessing some of you guys did work like this in primary school. Despite this, you still need to do your pre-learning. So pause the video now and do questions 1 and 2 in the new book and questions 4 and 5 in the old book. And when you finish those, we'll see you in the next section. A circle is defined as all of the points that are a certain distance from a point. So let's just start from this point and marking in 8 points that are exactly 3 units away. Now you can see this already looks like a circle. The distance from the center to the edge is called the radius. And using the wonders of OneNote, let me draw a perfect circle, which I'm going to need to drag into place. And you can see that these points I've marked out earlier are pretty much all on the circle. Also notice that 2 radii in opposite directions are called the diameter. Let's pop over to GeoGebra, where I can demonstrate this a lot more clearly, and you can follow this link to play with the applet anytime that you like. So here we start with a point that is represented in blue and this red arrow that has a length of 1. As I rotate the arrow, the trace of where it's being draws out points that are on a circle. So this radius 1 defines that circle. Well, in fact, it defines this circle. The distance you travel around the circle is called the circumference. And it turns out that if you measure the circumference of a circle and divide it by a diameter, you're always going to get a number that is very close to 3.14 and a lot of decimal places. This of course depends on how accurate your measurement is, but you can test this yourself at home with a piece of string around a round thing like a can, and this number is called pi. So if we start calling the circumference c and the diameter d, then we've already stated that c over d is equal to pi. But because the diameter is actually equal to 2 times the radius, we can say that c divided by 2r is equal to pi. And this gives us the formula for the circumference of a circle, which is c is equal to 2 pi times r. So this means that we define the circle as all the points that are exact distance r from the point. The distance around the circle is also defined as 2 pi times r. So these circles have helped us discover this wonderful number pi. Pi is a Greek letter, so obviously we've known about this for thousands of years. We know now it's an irrational number. The Greeks didn't know that, but they knew it was a complicated number. Archimedes of Syracuse, which is actually a place in Sicily, was one of the best mathematicians of the classical age. So he made a good estimate of what pi is, and it had to be an estimate because pi is an irrational number, using a method that I'm going to demonstrate now with GeoGebra. And here is a link to the applet they'll be using. If we start with a circle that has a radius of 1, we can fill it with 6 equilateral triangles. Their edges are as long as a radius, which is 1. So counting the outside edges, the first estimate for the circumference is 6. So if 2 pi times a radius of 1 is 6, that means that our first estimate is 2 pi is equal to 6, i.e. pi is now equal to 3. Obviously this is a very rough estimate because you can still see that we've got gaps between the lines in the circle. However, if we were to draw these lines here, we would create new triangles by splitting those ones in half. And now we have 12 triangles, and adding up the lengths on the outside there, we now have an estimate of pi that's close to 3.1. So if we remove this circle and crank up the steps, we can see the estimation gets closer and closer to pi. So after 6 steps, our estimation for pi is 3.14, and after 9 steps, our estimation for pi is 3.14159. The way we figure out these lengths will be a challenge for you in our next lesson. But as a heads up, Let's look at one triangle at a time. We know that halfway around the circle equals pi, because that's half the circumference. So 3 times 1 in this estimation is pi. We can set up 2 new triangles like this, and in our next class we're going to use Pythagoras to figure out the red and blue side lengths. Clicking estimation brings up this written explanation of what the estimation of pi is after this many steps. We can see as we go through more and more steps of this process, we get closer to pi. But more about this next week in the challenges. When you're asked to figure out the circumference of a circle, you certainly don't need to use Archimedes' method to figure out pi. You just need to use the pi function on your calculator, like a normal number, and then round to the required number of decimal places. So for those of you who are using the green calculator, you can find the pi button here. Just where my mouse is pointing, if you press pi. So for example, 3 pi is equal to 3 times pi. Now that's just given us 3 pi. So if you want to know the exact answer, put a decimal place in there. So 3 decimal place times pi. Okay, now you can see a number 9.4 yada yada. So that decimal place tells the calculator, please don't give me a fancy number, I need to know the exact digits. If you were to use a CAS calculator, it's a very similar process. The difference of course being how complicated a CAS can be. So if you look down here where my mouse is, you can see that pi button. Click that and a number of options will come up. So you can choose pi and there it is. Press enter and it's just said pi. What if we said 1 point times pi? There we go. So don't forget to use that decimal place. Okay, let's use all this in example 2, where we have a circle with a radius of r centimeters. And for example 2, we have to round the following questions to 2 decimal places. So in part A, we need to figure out the circumference if r is equal to 2.5. So because the circumference is equal to 2 pi r, we can just sub in those numbers. So 2 pi times 2.5. And before we use the calculator, let's just do the 2 times 2.5. So we end up with 5 times pi. And at this point, you need a calculator. So I could go back and use one of those other calculators, or I could just type this out in OneNote. So here we have 15.707. So 2 decimal places, we use a 7 to round the 0 up to 1. So our answer is 15.71 for 2 decimal places. Okay, that was pretty easy. Let's move on to part B, where we need to find the rule for r in terms of c. So this is just basically asking us to solve that equation for r. In other words, manipulate what we know to find r on its own. So let's start off with the equation as we know it. C, the circumference, is equal to 2 pi r. And to get r on its own, I need to divide both sides by 2 pi. So that means that r is equal to c divided by 2 pi. Okay, that's all they wanted us to do there, okay? So just solving for r. All right, let's just move straight on to part C, where we have to figure out what would the radius be of a circle that has a circumference of 10 centimeters. So clearly part B has made that easy for us. We know that the radius is going to equal c divided by 2 pi. So let's start off writing that out. And subbing in 10 for our circumference, we now have 10 over 2 pi. And cancelling out the 2, we have 5 divided by pi. Once again, we need a calculator here, so let's just use the OneNote calculator. So we have an answer of 1.591 and some more. We don't need to round the 9 because the third number is a 1. So 1.59 is 2 decimal places. Also notice how I've used pi in the OneNote. There's no pi symbol, we just type the letters pi, which is the old Greek letter for p. Alright, that's really straightforward, I hope. So at this point you should pause the video and work on questions 4 in the new book and question 7 in the old book. And then we'll see you in the next section. This Pac-Man shape is called a sector of a circle. A sector is formed by making straight cuts from the edge of the circle to the middle, then removing that piece to form that Pac-Man shape. When finding the perimeter of a sector, there are 2 components to consider. The first of these components are the straight lines. Now, any line from the edge to the middle of a circle is by definition the radius. So the mouth of the Pac-Man is 2 radii, which is equal to 2r. The second component is technically called the arc, but you might want to call it the round bit. Well, the round bit is just a fraction of a circle. So we know for any circle, such as this one with a radius r, the circumference is 2 pi r. Then the round bit, such as this one, defined by the angle A, is A degrees divided by 360 degrees of a circle, because 360 makes up the whole circle. And this A divided by 360 reduces to the fraction of the circle that the arc or round bit makes. So for example, if A was equal to 180 degrees, then A divided by 360 equals 180 divided by 360, which is just a half. So therefore, the length of the arc is A degrees divided by 360 multiplied by a circumference of a circle. And we know the circumference of a circle is 2 pi r, so the circumference is A degrees divided by 360 degrees multiplied by 2 pi r. So if we put the arc and the straight lines together, that means that the total perimeter of the sector is the arc length plus 2 radii, and we know that's equal to A degrees on 360 times 2 pi r plus 2r. And if I factor out the 2r, we're left with 2r times A on 360 pi plus 1. This formula will be much easier to use on a calculator. There's one thing to look out for though. Sometimes you're given a different angle than the one that you want in the formula. For example, you might have a sector like this. Well, that's terribly drawn. But they've given you this angle B. However, we want this angle A. So in this case, you're going to use your geometric reasoning and know that A is going to equal 360 minus B. So look out for that one. All right, let's get straight on to example 3, where we're going to be working with this sector that has a radius of 3 centimeters and an angle of 240 degrees. Not having a sector and inked a shape is really showing up my terrible artistic skills here, right? Okay, so part A is asking us to find the exact perimeter. So hopefully you remember from our unit with surds that exact means leaving the statement including irrational numbers. In this case, it's pi. So let's just write out the formula is P equals 2r times A degrees on 360 degrees times pi plus 1. So subbing in our angle and our radius, we now have 2 times 3 for the radius, and our angle is 240, so 240 degrees on pi plus 1 in the brackets. I mean 240 degrees divided by 360 times pi plus 1. So cleaning this up a bit, 2 times 3 is 6, and 12 divides 24 and 36, so plus that 0 there. So 240 divided by 360 is actually 2/3. So we're left with 2/3 of pi plus 1 in the brackets. And 2/3 times 6 is 4, and 1 times 6 is 1. So we're left with 4 pi plus 6. So that's the exact answer, okay? So we're going to go on to part B, where they ask us to estimate the perimeter, rounding to 1 decimal place. So this is where we use our calculator, and I'll put this in a big font because I know you can't see it normally. And it's worth doing that because I want to show you how easy it is to use OneNote as a calculator as well. So 4 pi plus 6 is 4 times pi plus 6. And then all you do is type equals and press space. So now we're left with an answer of 18.56 yada yada. So the 6 makes the 5 round up to a 6. So we'll say that 4 pi plus 6 is equal to 18.6. All right, so that's a lesson in working on the sector, but also a lesson estimating pi rounding using the calculator. All right, so that's it for the example. As I said, you're going to need to look out for the tricky ones where they give you the different angle. Anyhow, pause the video now and work on questions 5 in the new book and questions 8 in the old book. And then I'll see you in the summary. Okay, this lesson has no extra challenges, and I think I've covered everything to the best of my ability. So let's just get stuck in and get straight to the summary, where you need to know that to be successful in this lesson, you will know how to convert between metric units of length, know the meaning of the terms perimeter, circumference and sector, review how to find the perimeter of a closed shape, be able to find the circumference of a circle and the perimeter of a sector, and be able to find both exact and rounded answers to problems involving perimeters. Alright, so that's it. Just make sure you work hard and get this lesson complete. In the following 2 lessons, there's going to be challenges that I expect you to do. See you in the next video or in class. Bye.